Hi, today we're going to be talking about hypothesis tests. We're going to begin by going through the main elements of a hypothesis test, and then we're going to walk through an example together in this video. So first of all, what are hypothesis tests? Well, there are four main steps, and we're just going to explain these briefly. They might not make a whole lot of sense right now, but we'll circle back and explain them in more detail in the next video, and you'll see how these elements play out in an example in this video. So the first step is to select what's called a null hypothesis and an alternative hypothesis. So those are two different hypotheses that you're going to have, and they're going to be statements about population parameters. If you remember, whenever we're doing statistical inference, which hypotheses tests are one of the main tools for statistical inference, whenever we do statistical inference, we're generally trying to draw conclusions about a population, not about a sample. That would be descriptive statistics if we're just talking about the data that we have on our hard drive, talking about our sample. The second step in a hypothesis test, after we've written up these couple of hypotheses, is to select what's called an alpha level. This alpha level is basically going to say how often we're willing to be wrong with this process that we're using. Because there's always uncertainty in order to draw a conclusion, there's always the risk that we're going to be wrong. And so this is where we select what level of tolerance we have for being wrong. The third step in a hypothesis test is that we're going to calculate what's called a p-value using a statistical model, which is going to require assumptions in order to evaluate our sample. This is in many ways the most complicated part of the hypothesis test. But Stata is going to, or whatever statistical software you use, is generally going to create these calculations in the background for you. So you're not going to have to make them yourself. One of the main challenges, though, for people doing statistical inference is thinking about the assumptions that they have to make in order to be able to do statistical inference. And those assumptions are going to come to bear in how we compute the p-value in step 3. So sometimes there are alternative models that we might be able to use that make different assumptions. That kind of goes beyond the scope of this course. For this course, we usually stick with very simple models that have very simple assumptions. But sometimes with more complicated models, there are competing models that have different assumptions, and different models might give you different p-values. All right, once we have a p-value, we move on to the fourth step, which is to compare the p-value to the alpha level that we selected in step 2. And there's two outcomes that could result. First of all, p could be less than alpha, in which case we're going to reject the null hypothesis, conclude that the null hypothesis must be false, and that the alternative hypothesis must be true. In other words, we're going to accept the alternative hypothesis. The other outcome that we could reach is that we could have p be greater than alpha, in which case we're going to fail to reject the null hypothesis, and we're going to conclude nothing. Or have inconclusive results. So this is something we'll circle back to, but it's really important that the two outcomes, the two conclusions that we could reach, one of those possible conclusions is to be able to say we can't conclude anything. We just don't have enough data. We don't have enough information to really reach a good result. So we're going to have an inconclusive result. The other possibility is that we say, turns out that the null hypothesis looks like it's false and the alternative hypothesis must be true. Again, this is just to give you a brief overview of the process, and all of these pieces are going to be explained a lot more throughout this video and in the coming videos. So let's look at an example before we define all of these terms to help give us a framework for thinking about what we mean by hypothesis testing. So for this example, we're going to be thinking about ADHD medication. This example is explained in our textbook, and you can also click on this link that's provided here in the lecture notes to see a more complete explanation of the studies that were done that created this or the study that was done to create this data. So the basic idea is that the subjects in this study are children who have ADHD, and they're asked to complete what they call a delayed gratification task multiple times. And they're going to complete these tasks on different occasions when they either are given a drug or not given a drug or given different doses of the drug. And so our main concern, this study is a bit more complicated than the data that we're going to be looking at, but we're just going to be focusing on how did the child perform on this delayed gratification task when they had no drug, specifically they had a placebo, so maybe some sort of sugar pill or something like that, versus when they got a 0.6 milligram dose of methylphenidate. Clearly, I am not a researcher in this area of medicine, so I don't know how to pronounce this word, but you get the idea. They're getting this Ritalin is the brand name of this medication. So what we want to do is we want to see, do the children perform differently on this delayed gratification test when they either don't have the drug versus when they do have the drug? The same child is performing this task multiple times, either with the medication or without the medication. So the key variable that we're going to be examining is just a measure of the difference between the scores that they get on this test those two different times that they take it. Specifically, we're going to take the score that they got with the drug and subtract from that the score that they got without the drug. And that is going to be our main variable, is the difference in how they scored under these two different conditions, when they had the drug versus when they didn't have the drug. So now we have to start thinking about the steps of the hypothesis test. So the first step asked us to think about creating a null hypothesis. And in order to create a null hypothesis, the first thing we want to do is we want to come up with some sort of baseline. In this case, the baseline, the most natural baseline to think about is, well, what if the drug has no effect? If the drug has no effect, then the difference, the average difference in how the students score between these two conditions should be 0. And so we can say that the population mean would be 0 if the drug has no effect. And we say the population mean because for any individual student, they might happen to score worse on the one time versus the other time. There's going to be the what people score on these tests tends to bounce around a little bit. We have some noise in the way that we measure things, as with most variables that social scientists care about. And so because of that, we're saying that if we had tons and tons of people take this test, tons and tons of children, we gave it to everyone, we would expect that the mean difference to be 0 across all the kids if the drug had no effect. So 0 is going to be our baseline. We're going to be thinking about what if the average value of this variable, the difference between the two times the test is taken, what if the average is equal to 0? In other words, what if there's no effect? So again, step 1 of the hypothesis is to write the null and the alternative hypothesis. Our null hypothesis is where we're going to say maybe that baseline is true. Maybe it's the case that the average difference in scores is 0. In other words, the drug on average has no effect. Some students score better when they have the drug, some students don't, and that might just be random noise. That might not be the result of anything. So that's how we would write our null hypothesis. We would say mu, or the population mean, is equal to 0. We also want to write an alternative hypothesis, which is going to be the logical alternative of that. It's just going to say that mu does not equal 0. That's our alternative hypothesis. Step 2 of a hypothesis test is to select our alpha level. And we'll talk more about alpha levels in the next video. But the basic idea is that if you're not sure what your alpha level is supposed to be, you should probably just stick with 0.05. That means we're willing to be wrong 95% of the time with this approach. It corresponds to selecting a 95% confidence interval, which is something you've seen before in this class. So again, if you're not sure what to do for an alpha level, the default is typically 0.05 or 5%. So we would write that formally like this: alpha equals 0.05. All right, step 3, like I said, this tends to be the most complicated step. This is where we're going to calculate the p-value. We're going to use Stata to do this, and I've shown you right here the code that we can use to compute this. So what I'm going to do is I'm going to select this, copy it, and then I'm going to go and open up Stata, and it's going to take just a moment to load. Here we go. I'm going to paste this code into my command bar and I'm going to hit enter. And you can see that it's giving me some results. So before we look at those results, let's just open up this data set so that we get a better idea of what's going on. You can see that right here, there are 24 observations in this data set, 24 different children who participated in this study. This first column, the variable labeled D0, is showing us how they scored on this delayed gratification test when they got no medicine, when they had a placebo. And you can see that their scores varied quite a bit. and all of them are below 100 and greater than maybe about 20 or something like that. The second column is showing how that same child scored on a different occasion when they got the medicine. And I believe that they randomized the order in which they took these two tests. So some of these students probably took their test with the medication first and then did it without the medication later, so that it's not like students are learning and getting better at the test in the data set. So this is showing the scores that the students got when they had taken the medication. And then the third column is just calculating the difference between these two. You can see 62 minus 57 is equal to 5, and so the difference is recorded as 5, and so on and so forth. So if we just glance at this column, it looks like there are more positive scores than negative scores in this difference column. In other words, it looks like on average students tended to do better when they had the medication if we just eyeball it, although there are certainly some students who got a worse score when they took it with the medication. But again, we want to acknowledge that there's some random noise in this data. It's not like a student is always going to get the same score, even if they're in the same state. In other words, if they took this test lots and lots of times with the medication, they probably wouldn't get the same score every time. Same thing if they took the test several times without the medication, they wouldn't get the same score every time. So what we want to know is, are these differences big enough that we can conclude that there's a systematic tendency for someone to score higher when they have the medication? So that's what this hypothesis test is going to help us evaluate. So if we look at this test, the main thing that we want to consider, let me make a little bit more space so that we can see my thumbnail isn't getting in the way. So you can see right here that we get 3 sets of results here at the bottom. And these are for different types of hypothesis tests that we could conduct. We're just going to focus right now on this one in the middle. If you get results like this from Stata and you're not sure which part to focus on, usually I would recommend just focusing on the one in the middle. And this right here is actually our p-value, this 0.0038. You can see that it's labeled PR, which is for probability, which a p-value is just an abbreviation for a probability value, and then it's giving us some letters and symbols in here that we won't really worry about. But the point is, this is the p-value. So let's go back. Now that we know that the p-value is 0.0038, there's some other output here, but we're not going to worry about that for now. Let's go back to our slides and talk about what this result means. So you can see I put the results in the slides there. Step 3, of course, was to compute the p-value, and we got that result. We got 0.0038 as our result. So step 4 asks us to compare our p-value to our alpha value. Now, do you remember what we set as our alpha value? We set 0.05, which is the default, or 0.005. That's usually our default. So what we want to figure out is, was P bigger or smaller than our alpha? In other words, is P bigger or smaller than 0.05? And in this case, P is definitely smaller than 0.05. You can see that I rounded the number here and showed that it is smaller than 0.05. And if you skip back to our original slide with the outline of how to conduct a hypothesis test, you'll see that when P is less than alpha, we're going to reject the null hypothesis and accept the alternative hypothesis. And so in this case, what the alternative hypothesis said is that the mean difference between performance with and without the drug is not equal to 0. It's a non-zero value, which is why we're going to accept that. In other words, we see a big enough difference here between how the children are scoring on under the two different conditions that we're going to conclude that there is a real difference. It's not just due to statistical noise, that they're not scoring the same when they don't have the medication, when they do have the medication. So if we put this into just ordinary language, our conclusion in step 4 is that the medication has an effect on children's delayed gratification. That's what we learned from this study. All right, that's it for this video. In the next video, we will break down the elements of the hypothesis test and explain what these different terms mean in more detail.